Okay, throw anything at me. What do you know about Pythagorean theorem? Whatever you want at me, throw at me. Relax. 1. Anna, what do you know about it?
It can be used to find a missing side of a triangle.
Not just any triangle.
A right triangle.
Okay, let's start there, everyone. You got to have a right triangle to do Pythagorean theorem. It finds a side. All right, what else do we know about Pythag? It's got to be in a right triangle, and it's got to be find a missing side. 8. Anything else?
It's usually used to find the hypotenuse.
It can be, or a leg. What is the Pythagorean theorem, Sophia? That's what.
A squared plus b squared.
There you go. A squared plus b squared equals c squared. And I got to slow down here to make sure we're good on what A, B, and C mean. A and B, those are your legs. They're the sides that make the right angle. And C's your hypotenuse. Okay, C's the hypotenuse. Right triangles only. All right. So I want to use Pythag in a different way today. Take a look at my parallelogram. Find the perimeter for me. And we're going to leave our answer in simplest radical form. Parallelogram, what do you know about opposite sides? So we can start this. 6 opposite sides in a parallelogram. They're congruent. So does everyone see how one side's 11 at the bottom? So automatically the opposite side will be 11. Opposite sides congruent. What do you know? Again, how do I want to put this? Perimeter. What's perimeter mean to you? Perimeter. What do I need to find? 3. Perimeter.
Some of the sides.
Yep. How many sides then?
There's 4 sides.
There's 4 sides. I already know 2, 11 and 11. How can I find the other 2? Everyone see the right triangle that I formed here? I can find this side here by doing Pythagorean theorem. So a little different way to use Pythagorean theorem. Can you set that up for me? What's going to go in for A, B, and C? What's Pythagorean theorem going to look like on that right triangle of 2, 6, and C now? Here we go. 8.
2 squared plus 6 squared equals c squared.
Good. Notice how Sophia gave me the legs for A and B. 2 squared, 6 squared, and yes, we are looking for the hypotenuse here. Four and 36 equals c squared. 40 equals c squared. At this point, what do I need to do on both sides? I know most of you know, but I'm just checking. 11, what do I do on both sides here? Square, take the square root of both sides, yep. And notice my directions say simplest radical form. So I need your help breaking down 40, please. Go ahead and break down 40 into 2 radicals, a perfect square, and one that's not. What's 40 break down into? 3. 4 and 10. Square root of 4? 2. So I got 2 square root of 10. Sorry. 2 square root of 10. Means the other side is 2 square root of 10. All right, perimeter time now. So we got 2 square root of 10 plus 2 square root of 10 plus 11 plus 11. And be honest here with me, did you guys do radicals at all last year?
Yeah. A little bit.
Okay, all right, that's fine. I just asked because what can you add? Because you can't add all 4 of these. Let's make that clear. You can't add all 4 of these. All right? You can add the ones that have radical 10s in front, but you can't add them with the 11s. So if I have 2 radical 10s and 2 radical 10s, how many total radical 10s do I have? I have 4. I just add the numbers out in front. I don't add the numbers underneath the radical. We're good? And then I can do 11 and 11 to give me 22. I cannot Cannot add those two because the 22 does not have a radical 10 with it. That's it. We're done. Here's the perimeter in simplest radical form. We're done. We all right? Because that's probably not the only time you're going to have to add radicals. Only add radicals if what's underneath is the same. If this was a 7, you can't add them. You're done. So it would be 2 radical 10 plus 2 radical 7 plus 22, and I'd be done. You can only add radicals when what's underneath is the same. All good? All right, let's keep using Pythag a little bit differently. Our boy Big Al here. He always makes an appearance in these problems and tests and quizzes, if you haven't noticed. So to get from point A to point B, Big Al must avoid walking through a pond. All right, help me out. 34 meters south.
East.
My daughter came home with this the other day. Never eat soggy wheat. That's what they're teaching them now in 3rd grade. Northeast, southwest. So we're going 34 meters south and 41 meters east. So how many total meters did he walk already? Because we got to see how much he could save by walking through the pond, if he could walk on the pond. So right now he did what? He's walked 34 and 41 meters for a total of, 75 meters? All right, well, how much could he have done walking through the pond? So he did 31. So we already know he's got 75 meters down. But what could it have been if he walked through the pond? Pythagorean theorem. Can you set it up for me? 4? You want to set up Pythag here?
34 squared plus 41 squared equals c squared.
Yep, good. And we don't need we don't need to leave it in simplest radical form because look at directions. To the nearest 1/10 of a meter at the end of the problem, at the end. So I have 2,837 equals c squared. Take the square root of both sides. Now I have a question for you. And this question is going to come up more and more. Is this my answer, whatever I get for c here? How much you saved, is that my answer? No, and I asked you that for this reason. If it's not your final answer, we don't round in the middle of a problem. So that number right now that's staring you in the face in your calculator, when you take the square root of 2837, I'm not rounding that. I'm writing that all out. I don't round a thing until my final answer. So if he could walk through the pond, he'd actually walk 53.263495994 meters. That's not my final answer, so I don't want you to round it. Now let's answer the question. How do you find out how much he would have saved if he could walk through the pond? We know he walked 75 meters total, but walking through the pond, he could have did 53. How are you going to figure out how much he saved? 8.
You subtract 53 point whatever from 75.
Yep, I like the whatever. There you go. That's how much he's going to save. Now I round at the end. You don't round anything until the very end of the problem. That's why I keep that 53 and whatever. to the nearest tenth. Nearest tenth. How much would Big Al save if he could walk on water? 12?
21.7.
There you go, 21.7 meters. He walked 75. Could have walked 53. So we're going to say 21. Walk on water?
No, not walk up. It's only 20 meters. It's not that much.
All right. You don't want to get your shoes wet.
Yeah.
Right? Maybe drown.
Yeah.
That would be devastating. Yeah. Any questions there? All right. How about a high level? Oh, what was that? Oh, there he is. It's been a while, huh? God. It's been a while. All right. I do have all three sides of a right triangle, so I can do Pythagorean theorem to find x. You guys are going to have to really bust out some algebra 1 moves here. What are my a and b values according to that triangle? What are the 2 leg values? 2 legs on this right triangle, 8.
8 and x minus 4.
There you go. So, hey, everybody, 8 squared plus the entire side, x minus 4 squared. We'll talk about how to handle that. And then how about your hypotenuse? How long is your hypotenuse in this one to plug in for C? 10. X and I squared. So everyone see A, B, and C plugged in appropriately. All right, no problem. 64, right? 8 squared, 64. Now you got to make your algebra teacher proud last year. X minus 4 squared. Oh! Don't you dare be pulling this right here. Oh, that's x squared minus 16. No. No. No, they'd be crying right now. Anybody know how you handle that from last year? All right, well, I'm not going to give it away. How do we know 8 squared was 64? What'd you do in your head? What'd you do, Spencer? 8 times 8. What's 3 squared? 3 times 3.
Oh, I actually think do you do x minus 4 times x minus 4?
You times it by itself, correct. And you got to do a little double distribution FOIL, so I'll do it with you so you don't get nervous. All right, who's up here? Big timer. 9. Who's 9? Okay, let's go. That one. Ready? X times x. X times negative 4. Okay, let's now distribute the negative 4. What do we add now first? We'll combine those in a second. And then what do I got at the end? Plus 16. Wow, there's a lot to clean up on that left side, huh? X squared, what's the deal with your x's? How many you got? 1. How many x's do we have left here, Anna? Negative 8x. And then combine your 16 and 64. What are we looking at there? 6 plus 80 equals x squared. Hard little upper level algebra here. What's your next move? What's your next move up here? We got a lot going on there. Oh, please don't call on me. Please don't. Who's got 5?
I'm 5.
Oh, jeez.
Do we?
Go. I'll listen to anything. Go ahead.
We subtract x squared, right?
Sure, we can.
Yeah.
That's fine. And what's going to happen when we do?
Just negative.
Well, we got x minus x squared. He's right, minus x squared. But what's going to happen with the x squareds? What happens over here?
Just gone.
See ya, right? Go ahead. What's left, Abbott? Come on.
Negative 8x plus 80
And then I
equals 0.
equals 0. Yeah, you guys can solve this. Solve it for x now. Right? We don't need anything fancy. The x squareds cancel. Woo! I don't have to factor. Now solve it for x. Move the 80 over and do your thing. What do you end up with for x? 4?
Negative
How'd you move the 80 over?
Subtracted.
And then what'd you move over?
Oh, it's negative. I missed the negative 8.
Sure you did.
So it would be negative 80 divided by negative 8.
That's what I'm waiting on. This guy.
10.
All right, there you go. Good. 10. This is what I wanted to focus on here. All right. If anything is squared, you got to rewrite it twice. All right, we good? Before I show you another way to use Pythag other than define a side. Before I do that, what's an acute triangle to you guys? Acute triangle? How do I know a triangle's acute?
The sides are less than 90 degrees.
Sides?
Or, sorry, angles.
All angles less than 90. What's the other type? Obtuse. That means one angle is greater than 90, and then we have our right triangle. That's also what we can use Pythagorean theorem for. Forgot Genie, too. You can use Pythagorean theorem to see if a triangle is acute, or if it's obtuse, or if it's right, just by knowing the sides. I don't need to know anything about the angles. If you give me 3 sides of a triangle, I can tell you if it's obtuse, obtuse, or right by using the Pythagorean theorem, and here's how. Instead of reading this all to you, let's do a problem. 9, 12, and 15. If I have 3 sides that are 9, 12, and 15, would that be a acute, obtuse, or a right triangle? Here's how you figure out. You take the 2 smaller sides for A and B. So my 2 smaller sides, 9 and 12, and I do 9 squared plus 12 squared. And I compare it to the biggest side, 15 squared. And I'm going to see how that compares. If one side's bigger, we're going to call it acute or obtuse. If they're equal, it's a right triangle. So we do 9 squared, 81, plus 144. 15 squared, 2. Is that 225?
Yeah.
225. And what do you notice? 81 and 144? 225, right? And 225. They're equal to each other. If they are equal to each other, your triangle is a right triangle. Makes sense. It fits in the Pythagorean theorem. And Pythagorean theorem only works for right triangles. So if they're equal, if a squared plus b squared equals c squared, it's a right triangle. That's not going to be the case in part B. 10, 11, 13. Is that going to be acute, obtuse, or a right triangle? Well, do you take the 2 smaller sides, 10 squared plus 11 squared, how does that compare to the largest side, 13 squared? What do we got? 100 plus 121. How does that compare to 169? $221 and 169. If your a squared plus b squared is bigger, if your a squared plus b squared is bigger, we look at our chart here. If it's bigger, then it's going to be acute. All right. If a squared plus b squared is bigger, that bad boy is, I'm not going to go down that. I don't have time today. Acute triangle. Okay. If c squared is bigger, it's obtuse. All right. But if a squared plus b squared is bigger, it's acute. If c squared is bigger, it's obtuse. Questions? We got one more, right? Oh, you're going to hate. Not like you've already hated it. All right, let's graph it. Pinwheels. Okay, acute, obtuse, or right. And it's not going to be, oh, let's pick this because it looks like it. Nope, let's put some math behind it. If you're going to tell me if this is acute, right, or obtuse, I need to know the side length so I can plug it in the Pythagorean theorem. All right, we know how we're going to have to find the side lengths. Distance formula, right? Distance formula. So let's review that distance formula again, or Pythagorean theorem if you want. X2 minus x1 squared plus y2 minus y1 squared. And to make our lives easier and for this to go quicker, here we go. Abbott, you pick a side for your group.
XY.
Okay, you guys got XY. Rachel, pick a group for the ladies group here. ZY. And the two groups in the back, you guys have XZ. Okay, you have XZ. You do not have to leave it in simplest radical form. Just leave whatever the number is underneath the radical, leave it like that. All right, so just do your side only. And take a peek around, make sure you guys agree before you let me know what it is. All right, make sure you copy it. Make sure you write it down if you weren't responsible for it. XY group, what do we think? What's underneath the radical? Square root of 29. Good. XY is the square root of 29. ZY group, what do you got for me? 20. Yep. And no reason to break it down. Nothing says simplest radical form, so I wouldn't even break it down. And then anybody in the back, what do we got for XZ? 13. Square root of 13. Good. All right, now how do we figure out if it's acute, right, or obtuse? We plug it into Pythagorean theorem and see how the sides compare. First thing, can we figure out what are the two smallest sides? Because that's going to be A and B. What are the two smallest sides up here? Square root of? Okay, 13, so ready? Square root of 13 squared, right? A squared plus, next smallest side? Square root of 20 squared. How does that compare to square root of 29 squared? And you can do it on your calculator and you'll figure out something real quick. What happens when I square a radical? So what happened when you squared 13? You got square radical 13, you got 13 out, plus 20. And then over here you got 29. So what do we notice? 33, 29, the a squared plus b squared was bigger. So this was what type of triangle up here? 3, what type of triangle? The acute, right? The a squared plus b squared was bigger. So we are right on finding if it's an acute, obtuse, or right just by the sides now. And then I want you and your group to look over the last problem and see what you think. Big Al and Little Mike. Big Al says they're congruent. Little Mike says they're similar. We've talked about both when triangles are congruent and when they're similar. talk about it. What do you guys think? Are they both correct? I see some of you guys using Pythag to find the missing sides. Good idea. What was the missing side on the first right triangle? Missing side here when you did Pythag?
C squared.
Yep, which was what? I'm just looking for how long it was.
13.
13 after you do Pythag? That was 13. Anybody find the missing side in the second one? Now here, we would have done 5 squared plus b squared equals 13 squared, right? Because 13 was the hypotenuse. Anybody find the missing side here? This would have been 12. All right, so are they congruent? Let's go big Al first. Are they congruent? By what method? We could go a lot of methods, right? So they are congruent. Anybody go ahead, throw out a method. Side, side, side. You could do side, angle, side. HL. How about similar? His brother there, little Mike, says they're similar. What do we think? Similar? Why? Why are you shaking? Why are we saying no?
Can they not be similar if they're congruent, right, or no?
They are similar.
Okay, I'm having some debate here. Good.
So if all the angles are the same, they'd be similar.
Okay.
Or we could say we go angle, angle. What are the other? Remember the other methods? Side, side, side. Similarity. Are these sides in the same 5 to 5, 12 to 12, 13 to 13? Are they in the same ratio? Yeah, they are. And also remember, if two triangles are congruent, they're also similar. Okay, not the other way, but if two triangles are congruent, they are similar. So they are similar by, we could go SSS, similarity. Or if two triangles are congruent, they are similar. So they're both correct. They are congruent and they are similar. This was a Regents question a couple years ago. Okay, all good. Only thing I'm going to ask you guys, please pay attention to the directions at the bottom of the page tonight in your textbook, because there are rounding directions I want you to follow, okay, for certain problems. All right, go ahead, let's get moving.